before a tornado destroyed this tower. So that tower is gone. It's been replaced. This is a 200-foot tower. That's a 9L, 6-meter Yagi at 50 feet. So this is a quadcopter that's taking these videos. And there's another 9L, 66-meter Yagi at 100 feet. Actually, it's about 80 feet. And that's not the end of it. There's another 9L, 6-meter Yagi here at about 110 feet. This is all just a crumpled pile of junk metal right now.
So this is my favorite 6-meter antenna, but let me emphasize, you do not need anything like this in order to really enjoy the beam. It's very easy to build 6-meter antennas. You can buy the parts you need either locally from aluminum tubing suppliers, metal suppliers, but also you can order it online from DX Engineering and other suppliers. For any Yagi antenna, whether it's HF or 6 meters or anything else, it's extremely important to protect the joints from seizing and from corrosion. And the material that I use is this JetLube SS30. I've been using it for nearly 50 years. And never had a problem with this material drying. And if the lubricant, anti-seize lubricant that you use does dry out, it actually makes the elements harder to take apart rather than easier to take apart. So I use this material because it never dries out. You can also buy the materials for constructing 6-meter Yagis either from DX Engineering or from your favorite metal supplier. Some people like to use square aluminum tubing for 6-meter booms. You can buy that at Metals Depot and other places. Used to be people fabricated Yagi antennas using U-bolts, but now this material that's used for piping in refineries and chemical plants is widely available and inexpensive. And you can see in the photograph how it's used to attach the element to a mounting plate, which then goes onto the boom. And there are many, many companies that sell these clamps, and Wilson Company is just one of many. For 6-meter antennas or HF antennas, it's very important to isolate the outside of the coax feed line from the antenna-driven element. I often ask cams this simple question, and that is, how many terminals are there at the end of a piece of coaxial cable? Or how many connections can you make to the end? Well, the correct answer is that a coaxial cable is a 3-terminal device. It's the center conductor. We all agree to that. But then the inside of the shield is separate from the outside of the shield. So you have signals carried on the inside of the shield, which should be the same magnitude as the signals on the center conductor. But then you have signals on the outside of the shield, and that is all RFI, unwanted RFI. So what we need to do with any coaxially fed antenna is to isolate the outside of the coax shield from the driven element of the antenna. The way we do that is with a choke. There's a couple of really good articles about this, and the links to those articles are shown on this slide. So here's what some popular chokes look like. Hams have been using coiled coax chokes for decades and decades. They work just fine for single band. But there's a problem, and that is we're using this coiled coax to create a resonant choke. And the capacitance in that resonant choke is determined by the capacitance between the turns of the coax. And the manufacturers do not control the capacitance of the outside jacket of their cable. So the only way to be sure that you've achieved resonance near 50 megahertz is to actually measure it with an antenna analyzer or some other suitable device. The other thing that's very important with any choke that you install on an antenna is you do not want to mount that choke directly on the boom of the antenna. All of the effort you've gone through to try to isolate the signals from the driven element, the signals on the outside of the coax from the driven element, most of that benefit is lost if you attach that choke directly to the boom. You don't want to do that. You want it to be a few inches from the boom to preserve its performance. So this is one type of choke. Another one that's increasingly popular is a choke fabricated from ferrite cores that are installed over RG213. And this is one of the chokes that you could either build yourself from parts you could order from DX Engineering or many other sources, or you can buy them already manufactured from at least 2 sources, and they're shown on the slide. So this is what it looks like when it's installed. It's mounted a few inches from the boom to preserve its performance, and then you connect your coax cable to the end of the choke. And this is a very, very high performance choke that isn't needed in most installations. But if you're in a really densely crowded urban area with a lot of RFI, this kind of performance can be achieved. And there's an excellent article about it shown on the link at the bottom of the slide. So now we've figured out how to get all this performance from simple antennas. But then we've got a problem on 6 meters, and that is coaxial cable gets to be pretty lossy. So, and how bad can it be? Well, RG8X is pretty popular coaxial cable on HF, but on 6 meters, it has 1 dB of loss for every 40 feet of RG8X. 40 feet won't even get us to the bottom of our 50-foot mast that we'd like to use on 6 meters. So that's not a very good choice. It's pretty lossy. For most of us, RG213 is a pretty good choice, but it still has 1 dB of loss for every 60 feet. So if your radio isn't sitting in a tent at the bottom of your mast, you're probably going to have at least 3 dB of loss by the time you get your RG213 back into the house. So what you'd really like to do on 6 meters is when you go to a handfest, try to find some half-inch 50 ohm hardline. And that can go 200 feet before you have a dB of loss. And this is really what you prefer to use on 6 meters if you can. Back in the day, we could get 3/4 inch cable TV hardline, but that's kind of hard to come by now. It's really excellent. And one thing for most installations is not needed is the really big hardlines like the 7/8 inch. You really don't need it unless the mast is very far from the house. And at the bottom of the slide, it shows that for 7/8 inch hardline, you have to go 475 feet before you have 1 dB less loss than half-inch hardline. So that's a pretty long distance. So save your money on the 7/8 inch hardline. But if you get it for a very low price, then go ahead and use it. But don't spend a lot of money on it unless your antenna is 500 feet from your house. So what about connectors? Both N connectors and UHF connectors are commonly used on 6 meters. The most important aspect of this is neither type of connector has any significant loss on the 6 meter band. If you do use UHF connectors, be sure you use high quality connectors, silver plated connectors, not these cheap plated connectors that are all too common. There is a reliability problem with N connectors, and that is N connectors, unlike UHF connectors, N connectors are precision devices. And it's absolutely necessary when installing an N connector that the depth of the center pin has to be preserved plus or minus 20 thousandths of an inch from its ideal location. And most of us don't have the skills needed to meet that kind of tolerance. Well, what happens if I can't get that center pin oriented within 20 thousandths of an inch of its optimum location? Well, if the pin is too deep into the connector by more than 20 thousandths of an inch, the connection is unreliable. And if the pin is 20 thousandths of an inch too far out of the connector, you can tell this because if you run your finger across the face of an N connector and you can feel the center pin extending out beyond the face of the connector, that pin is too long and it will damage the mating female connector. It causes the pins in the female connector to spread, and it loses connection force and makes a very reliable connection, and can actually cause the leaf on the female center pin connector to break off. So what I always recommend for most hams is don't use N connectors at all. Use UHF connectors. They're easy to install. But if you must use N connectors, and of course on 2 meters and above you should, make sure you use name brand connectors and make sure you use the type that have captive center pins. So the manufacturer has set this 20 thousandths of an inch pin depth tolerance, and you don't have to worry about being a high reliability, well-trained connector installer in order to do this. You can buy connectors now where instead of having a loose center pin in the bag, it's permanently installed inside the connector. Now, if you do use UHF connectors, it's really important not just to finger tighten them. And I know everybody listening to this presentation has got UHF connectors in their station and maybe even out on their antennas that they've only tightened by hand. And the problem with that is that it's unreliable. So what I recommend is just to use a pair of pliers or any kind of a wrench and just gently tighten your PL259 connectors, only about a quarter of a turn, just tight enough so you can't loosen them by hand. And that makes for a much more reliable PL259 connector. This is the worst possible place you can save a couple of dollars by buying cheap unbranded connectors and adapters. This is the connector I use throughout my station, the Amphenol 83-1SP. If you find any more characters in the part number other than 83-1SP, it's a much poorer quality connector. Amphenol makes a wide variety of connectors, but the only one that they sell that I recommend to hams is the one labeled exactly 83-1SP. And there are many other excellent connectors out there, but this is the one I use, and I've had excellent success for many, many years. When you install connectors outdoors, or if the case of a split-driven element, where you have to use solder lugs to connect to the driven element, it's very, very important that none of the center conductor of the coax cable, none of the dielectric, none of the shield is exposed to weather. Now, some hams like to use electrical tape to do this. It doesn't work. Electrical tape is not intended to be used for weatherproofing. It is not, never was, never will be. What you want to use for weatherproofing is tape that is intended for that purpose. And what I use is Scotch 130C. It's very widely available, and I'll show you where to get it in a moment. And it will preserve the value of your coaxial cable for many, many, many years. Electrical tape will not. It might look pretty, but it doesn't work. And this is what the center connection of coaxial cable to a split feed insulator should look like. I use stainless steel screws going through the driven element of the antenna, and I do not allow the solder lug to come in direct connection with the aluminum. That tends to cause an opportunity for corrosion to develop. So this, you can see in the photograph, if you look very closely, and you can probably see it more closely by looking at one of the slides afterwards, that the solder lug is not in direct contact with the aluminum. It's connected to the stainless steel screw and the nuts. And I also like to use a locking nut for the last nut in this assembly. One of the trade names is Nylock. So it helps to avoid having this nut loosen up and then having to spend hundreds of dollars to pay someone to go up on your tower and repair this. And I also use liquid electrical tape over the whole thing. This is the weatherproofing material that I use, Scotch 130C. It's available at any Home Depot anywhere in the United States. There's one downside to this rubber tape, and that is that its UV resistance is not that great. So I cover it with a couple of layers of Scotch 33. You know, it's the 21st century, and we don't read instructions anymore. We throw those away, and we just know how to use tape. Well, if you read those instructions for Scotch 130C, you'll discover it's supposed to be installed with the sticky side facing out. Yeah, that's right. Sticky side facing out. And it will also tell you that you're supposed to stretch this Scotch 130C to about 50% of its original width until it starts to change color. It starts to change from black to gray. Okay, so that's the last slide of my presentation, and I'm open to questions.
Thank you, Frank. Questions? Unmute yourself.
And of course, you can always send questions to my email address.
I have a question.
Sure, Stan, KC2K.
Frank, have you had any experience with TVI on 6 meters?
Hi, Stan. Thank you for that question. Well, years ago, I did. You know, back in the days when TVs had cathode ray tubes, and even in the days when there was only black and white and not color, 6 meters was a big problem, especially if there was channel 2 in your area and the signal wasn't that great. But now that essentially everybody gets their TV from cable, the TVI problem has gone away. And even for those people who have cut the cable and gone to getting TV off the air, almost all the channels are up in the upper part of the VHF range where 6 meter TVI is not a problem. So the simple answer to your question is no, I have not had a problem ever since the days that over the air channel 2 has gone away. That used to be a big problem.
Other questions? Unmute yourself.
This is Van.
Hi, Van.
WTBLT.
Okay, thanks, Frank. Great presentation. All the years I've been a ham, I did very little on 6 meters because of TVs with 50 megahertz channel 2s. So I kind of stayed away from it, but it's getting more and more exciting. Only question I have is it looks like 99.9% of the activity on 6 meters is FT8. Is there anything left on CW or voice?
Yeah, so that's the good and the bad. So yes, there is CW activity. It's not as much as it used to be. There's a little bit of sideband activity, but during the VHF contest, there's a lot more. During field day, there'll be somewhat more. So that's the bad news. The good news is that the amount of activity on FT8 is absolutely incredible. Absolutely incredible. So now we are aware of propagation opportunities on 6 meters that we were never aware of before because there wasn't enough opportunity to discover it. For example, the ability to make contacts between the east coast of the United States and China by sporadic-E. If someone had told you that 10 years ago, even 5 years ago, FT8 is only 5 years old. It just started to be used in 2017, just started. If anyone asked you that you could make contacts between the east coast of the United States and China before 2017, they would tell you that it's impossible, can't be done. Well, that's not true. Quite a number of East Coast stations made contacts, T8, with stations in China 2 weeks ago, and the same with stations in Korea. And my lucky neighbor had a contact with Taiwan. So, yeah, FT8 is good and bad. There's a lot of good to it. It's attracted a tremendous amount of activity to 6 meters. It's attracted a great deal of new hams who are interested in it, but it has come at the expense of some activity on CW and single sideband. You know, there's kind of a well-known thing about bank robbers back in the Depression era. And there was an FBI agent that interviewed one of these bank robbers and asked him, why do you always rob banks? And he had a very simple answer. And that is, I rob banks because that's where the money is. Fortunately, that's why we operate FT8, because that's where the money is. It's just unbelievable how much activity there is. So that's the good and bad of it, Van.
Okay, so you're saying most of the contacts you've been making are on FT8.
Yeah, if I didn't try to make any contacts with, 10 days ago, I made 40 contacts with Japan on FT8. And I was so busy. Every time I finished one contact, there was 6 more stations from Japan calling me. And I just didn't have time to go down to the CW band to see if I could make one contact. Because there were dozens of stations in Japan looking to make contact with me on FT8.
Okay, you've sold me. I guess I've got to take the jump and get on the FT8. Jim, you can stop chiding me now.
There you go.
Dan, you're going to enjoy it. It's going to be different than what you've experienced before, but you've experienced a lot of changes in the world since you've been around, and this is just one of those changes that's good and bad.
There you go. So, other questions for Frank?
Okay, so I guess we've gotten to the
Nothing
end. Yeah. I'll be happy to answer any questions that anyone has by email, either after this presentation or in the future. The most important takeaway from this is that 6 meters is a lot of fun. There's a tremendous amount of activity, but yeah, Van, it's mostly on FT8 now, and there's all kinds of long distance propagation that DX'ers will just find fascinating. So just get on the air and have some fun, and don't worry if you don't have an optimum system. You really don't need it. So thanks
Frank,
everybody for joining in.
Thanks so much for a great presentation tonight. So, and hope the weather is holding out by you there, because I was looking at the weather. There are some pretty bad thunderstorms.
Yeah, the thunderstorm has left, and the thing I hate most, and this happens at least once or twice a year, is when I hear a very loud thunderclap and a flash of light at the same moment. That means lightning has struck one of my towers. Happens once or twice a year, and it is not.
There you go. And that's the presentation on grounding, I'm sure.
Yep.
As well, too. So anyway, thank you on behalf of all of us.
You've got three people with their mic open.
Yeah, quick question, Frank. For those of us who can't get a tall enough tower to operate, this is Bruce Adamo, N2OQX. Have you got much experience with compressing the pattern using stacked antennas?
Sure. And in fact, I showed you this one stacked antenna at J1BK. So if you really want a really good antenna, copy this one. 50-foot crank-up tower with a pair of 8-element Yagis.
I was thinking about operating below 50 feet because my local ordinance won't let me get above 25. So it's going to have any experience with the pattern at that height with a stacked antenna.
Yeah, there's no advantage to be if you're limited to 25 feet. What I would do is put up the largest Yagi you can, but it doesn't have to be really large. If I were in that situation, I think I'd put up maybe if I could, a 5-element Yagi or a 6-element Yagi on a simple 25-foot mast. You'll be off to the races. Don't worry about it. It's not perfect. If you're on the air, chances are the guy with the perfect antenna is not going to be on the air.
Very good then. All right. Thanks for the info. It's a terrific presentation.
Yeah.
Okay, thank you.
If I may.
Yeah, go ahead.
If I may, this is Fred W2AAB. Good evening, Frank. Thank you for an excellent presentation again. This is the second time I've seen it. The first time was the FRC presentation. It's so great that you also came to FLARC. We're very glad to have you here. By the way, just as a point of information, I've been monitoring 5125 since this started, and the band has been open north-south pass. No DX, just to Florida if you want to work Florida. That's all I have to say. Good night. Thanks so much.
Yeah, well, thanks very much, and I'm glad you enjoyed the second running. There's a few minor changes in the presentation since the FRC one. What always happens is people ask questions after the presentation, and sometimes I will take that and make a little minor tweak in the presentation so that question is addressed. And of course, don't forget that I didn't read these slides. So there's a lot of information on these slides that I just couldn't read in a 1-hour presentation. So go back and look at the slides if you're interested, and you'll see there's a lot more detail there.
Perfect. Other questions or comments? Jim, help me out if I missed any.
Ed, you've got Bob with no last name.
Okay, Bob, go ahead.
Hi, it's Bob, WB2NVR. Thanks very much, Frank. I really enjoyed the presentation. Thank you, everybody, for letting me listen in. I have a question about cubicle quad antenna compared to the Yagi. A good friend of mine has, I think, a 3-element quad, and he thinks it's the best thing since sliced bread. How does that compare to the Yagi?
Yeah, well, quads are mechanically complex. Quads used to be really, really popular when I started in ham radio in the early 60s. And you don't find many quad antennas today, but they're very good antennas, but they're just complicated. So not many hams use them. They have a small advantage, but it's really small compared to a Yagi. So most hams build, a simple antenna like that. This antenna is a whole lot less complicated than a quad, and that's what most hams do. But if you want to use a quad, go for it. It'll work just fine.
I guess we're dating ourselves then. But thanks very much. I appreciate it. Right. Take care.
You're very welcome. And let me remind people that many of these slides have links at the bottom for even more detail. So if you want to dive into the nuts and bolts even deeper, there's all these links on the bottom of a lot of these slides.
Other questions?
Okay, guys, well, get on 6 meters and enjoy it. It's a lot of fun. We're right at the peak of the main operating season on the 6-meter band. We've got the CQ Worldwide VHF contest coming up in the middle of July. There'll be a tremendous amount of activity. But at this part of the year, there is 6-meter propagation every day. And that can occur anytime between dawn and 2 o'clock in the morning. But the best time, the most likely time, is late morning. So have a great time on 6 meters and enjoy all the fun. There's more activity than ever.